Let's now turn our attention to nomenclature and reactions of aldehydes and ketones. So the rules for naming aldehydes aren't very difficult from other rules we've learned in the past. We're still going to identify the parent chain, and the ending is now changed to al. And because aldehydes are at the end of a molecule, it's assumed that carbon number 1 is always going to be at the end, right? Because an aldehyde is C double bond OH. So by definition, that needs to be carbon number 1. That's the first carbon in your chain. And then all you need to do from there is identify your location of any other substituents. So let's look at this molecule. Well, let's look at both of these. Aldehydes are always at the end of molecules. They're always at the end of the chain because they are a carbonyl with a hydrogen, right? So by definition, this has got to be number 1. So 1, 2, 3, 4, 5. In this one, 1, 2, 3, 4, 5, 6. And so from there, all you need to do is identify any substituents you might have. So in the top one, we've got 2 bromos and 2 chloros. So we're going to put them in alphabetical order. 3,4-dibromo, 3,4-dichloro, pentanal. The ending becomes Al. And in our second example, this is 3-ethyl hexanal. When we name ketones, ketones are not guaranteed to be anywhere in the molecule in any particular place, right? As long as the carbonyl is on the interior of the molecule somewhere, it's a ketone. So you need to identify the location of the ketone. In an aldehyde, you don't need to put the 1 because it's assumed that the aldehyde is on carbon number 1. But in a ketone, you do need to put where that ketone is located in the chain, because it could be on carbon number 2 or 3 or 4 or 5 or wherever, right, depending on the length of your chain. And the ending becomes -one. It ends in ONE. And then after that, all we have to do is identify the location of any of our substituents. So we want a number so that the ketone gets the lowest number possible. Let's look at this one. We could number 1, 2, 3, 4, 5, or we can number 1, 2, 3, 4, 5. We're going to begin numbering from down here, though, because there are substituents over here. There aren't any substituents over here. Right? So this is going to be 1, 2, 3, 4, 5, so that our substituents are on carbons 2 and 3. With this one, we can number 1, 2, 3, 4, 5, 6, 7, 8, or we can number 1, 2, 3, 4, 5, 6, 7, 8. Obviously, we're going to number this way because 3 is a much, much smaller number. We want to give priority to the ketone. So my names are 2,3-dichloro, 5-nonanone, and 2,5-dimethyl, 3-octanone. Ending is ONE for a ketone. When we oxidize an aldehyde, we form a carboxylic acid. So when we oxidize an alcohol, we form an aldehyde. When we oxidize an aldehyde, we form a carboxylic acid. Right? So if I am oxidizing this aldehyde, this is the product I would get. We'll talk about how to name that product in our next lecture. And then when we reduce a carbonyl, we're going to get our alcohol back. So for instance, if I take my ketone, I've got to react this with hydrogen gas, and palladium's my catalyst here. I get my alcohol back. And then there's reduction of an aldehyde. Palladium's my catalyst. Again, I get my alcohol back. And that's a brief overview of nomenclature and reactions of aldehydes and ketones.